All right, so let's talk about what we mean by simplifying radicals. So for example, you did this before. This you've had in the previous lesson. The square root of 121. And really, when we talk about the radicals here, we're only going to be talking about square roots. That's all we're going to talk about with regards to these, is just square roots. So how do I simplify the square root of 121? When I say simplify, what is that equal to? 11, because 121 is a perfect square. And the square root of 121 is 11, because 11 times 11 is 121. All right, so remember your perfect squares. There are an infinite number of them, but the ones that you need to know for us right now is the smallest perfect square is 1. What's the next one? 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 25. 36. 49. 64. 8 times 8, 64. 9 times 9, 81. 10 times 10, 11 times 11. 12 times 12. 13 times 13. And so on, right? Okay, so those are your perfect squares, because when you take the square root of them, you get a whole number back. What's the square root of 64? The square root of 81, 9, and so on. Okay, so 121 is listed in here, right? So the square root of 121 is 11. So I simplified the square root of 121. It's 11. All right, number 2. The square root of 75. All right, now, again, you want to ask yourself, is 75 a perfect square? No. But to simplify, here's your thought process. I'm taking a square root, so all these are square roots, so you'll be looking for perfect squares. So is there a perfect square other than 1, because 1 goes into every number? Is there a perfect square listed here, and there are an infinite number of those, it doesn't just stop at 169, that goes into 75? And you always want to use the largest. It makes it a lot easier if you use the largest perfect square. Huh? 81 does not go into 75 evenly. Is there a perfect square listed here besides one that goes into 75 evenly? 25. 25. Because I can write 75 as a square root of 75 as a square root of 25 times 3. 25 times 3 is 75. You always want to make sure that when you write that radicand as a product, that one of your factors is a perfect square. Make sure it's a perfect square. That's what we mean by simplifying. You want to remove as many perfect squares as a factor as possible. Now, once you write like this, I need you to remember this now. See that square root of that product? Do y'all agree that that's the same thing as saying the square root of 25 times the square root of 3? No? Yeah, the same thing. Square root of 4 times the square root of 9 is the square root of 36, right? Square root of 36 is 6, correct? What's the square root of 4? 2. What's the square root of 9? Do you still get 6? Yeah. Okay. Now, that property only applies. See how I had the square root of 4 times the square root of 9, and then 4 times 9 is 36? That property only applies now if the indices are the same. Am I dealing with 2 square roots? Yes. As long as the indices are the same, then I can write as 1 square root. Okay? So notice when I wrote the square root of 36 as the square root of 4 times 9 like this, I still said square root because the indices have to be the same. So the square root of 25 times 3 is the square root of 25 times the square root of 3. Is there any of these I can simplify? Which one? Square root of 25. Because the square root of 25 is exactly what? 5. Can I simplify the square root of 3 further? No, because the only perfect square that goes into 3 is which one? 1. So your answer is 5 times the square root of 3. There's your answer. So I did simplify the square root of 75. So I simplify the square root of 75 as 5 times the square root of 3. Okay? Number 3, you have the square root of 18. Remember, all we're dealing with is square roots here. So you're looking at perfect squares. Is 18 a perfect square? 18 is a perfect square? No, 18 is not a perfect square. But is there a perfect square other than one that goes into 18? 9. The only perfect squares that go into 18 is 1 and 9, right? There's no other perfect squares listed there that goes into 18 evenly. So I'm going to rewrite this just like I did before. Make sure you write those steps. Otherwise, you're probably going to mess up somewhere if you don't. So I'm going to rewrite this as the square root of 9 times what? 2. Once you write as a product, then split it apart. Take the time and do this. So that's the square root of 9 times the square root of 2. Y'all agree with that? Okay. Is there any of these I can simplify? The square root of 9, which I know is what? So I get 3 square root of 2. Can I simplify the square root of 2? No, because the only perfect square that goes into 2 is 1. So there's your answer there. So the square root of 18 is just 3 square root of 2. And number 4, you have the square root of 175. The square root of 175. Is there a perfect square that goes into 175 other than 1? 25. 25. Use your calculator if you need to. 25 times what's 175? 7. So this becomes the square root of 25 times what? 7. In fact, 25 is the largest, right? So once you write this, the next step is to rewrite this, split them apart. So it'll be the square root of 25 times the square root of 7. Which of those can I simplify? Square root of 25, because the square root of 25 is just 5, so I get 5 square root of 7. Okay. Number 5. Number 5, suppose we had the square root of 81. What's that? 9. Because 81 is already a perfect square, so that's just 9. So the answer is 9. 6. All right. 6, suppose I had the square root of 72. The square root of 72. What perfect square besides 1 will go to 72? 9? Okay. Is that the largest? All right, let's think about this. Here's the way you want to think about this, okay? Yeah. So you said we have 72. Y'all agree? All right. So in your mind, you're saying, all right, I think 9 is a perfect square. I don't know if it's the largest, but is a perfect square that will go to 72. 9 times what? 72. 8. But then look at 8. Is there a perfect square that goes into 8? What is it? Yeah. 4. 4 times 2. So look at this 9 and this 4. What's 9 times 4? 36. So if you had said 9, and if you had said 9, you would have written it as this. Watch how you would have written it. You would have said 9 times 8, right? But then this 8 should have given it away, because what else can go into 8? What other perfect square can go into 8? 4. And 9 times 4 is 36. So at that point, I would have just written this. I would have said the square root of 36 times what? 2. Okay, now split it apart. I get the square root of 36 times the square root of 2. Is there any of these I can simplify?
36.
Square root of 36. What's the square root of 36? So what's the answer? 6 square root of 2. All right. Now, it's always best to use the largest. So if you did use 9 and you did not realize that 4 goes into 8, then here's what you would have had to do, which is fine. It was just taking a little bit longer to get the answer. So I'm going to do 6 again. Look at the square root of 72. So suppose someone did say the square root of 9 times 8, right? Rewrite it, split it apart. That's the square root of 9 times the square root of 8. Y'all agree? All right. Is there any of these I can simplify right away? I know right it is right off the bat. Square root of 9. What's the square root of 9? So I got 3 square root of 8. Now you see, in the ones we've done before, we always stopped. See, once I said 5 square root of 3, and I stopped and said that was the answer, right? I said 3 square root of 2, and I stopped. I said that was the answer. I said 5 square root of 7, that was the answer. I said 6 square root of 2, that was the answer. All right. Don't get into that mindset that once you simplify one part, you're done. See right here, 3 square root of 8, you would probably say that's the answer, but it's not. Because you need to always ask yourself, the square root of 3, is there a perfect square other than one that goes into 3? Yes or no? No. Is there a perfect square other than one that goes into 2? No. Is there a perfect square other than 7? Other than one that goes into 7? No. Is there a perfect square other than one that goes into 8? Yes. Which one? 4. So you want to keep doing this again then. You go through that same process over. So this becomes 3 times the square root of 4 times what? 2. So then you split this apart. So it becomes 3 square root of 4 times the square root of 2. See what I did? It helps if you do that. Now this part I can simplify right away. What's the square root of 4? 2. And 3 times 2 is 6. So I get 6 square root of 2. And you can't simplify the square root of 2 any further. But notice it's always best if you use the largest. It saves you a lot of steps. Use the largest. All right, number 7. All right, suppose number 7 you had the square root of 500. Square root of 500. What perfect square besides 1 will go into 500? 400? 100? Okay. So it'll be square root of 100 times 5, right? Split it apart. That's the square root of 100 times the square root of 5. What's the square root of 100? So the answer is 10 square root of 5. Agree? But someone else could have said, well, I'm going to use 25, right? Okay, so someone else could have said, all right, well, I know that the square root of 500 I can write as 25 times, not 40, is it? It's not 40. 20? You agree? Okay. And then split it apart, that's the square root of 25 times the square root of 20, right? But even before you did that, I want you to think about this. When you thought about that 500, because you can save yourself a lot of steps, even if you did say 25. In your mind, you're saying, all right, 500 is going to be 25 times 20. But look at this 20. What other perfect square goes into 20? 10 is not a perfect square. 4. And what is 25 times 4? 100. So then you would have realized, oh, I can use 100 instead. And then go back and use 100. Okay? But let's suppose you didn't do that and you stayed on this track. What's the square root of 25? So I get 5 square root of 20. And then you ask yourself, can I simplify the square root of 20? Yeah, because what other perfect square besides 1 will go into 20? 4. So then you'd say, all right, well, that's going to be 5 times the square root of 4 times what? 5. Now split this apart. So that'll be 5 times the square root of 4 times the square root of 5. And what's the square root of 5? 2. And what's 5 times 2? 5 times 2 is what? 10. So you get 10 square root of 5. And that's what you got here. But notice if you don't use the largest perfect square, you see all these steps? But even if you didn't think of the largest one, when you use this idea, use it. So you have 25 times 20, but you should realize 4 will go into 20, so then my largest perfect square then would be 25 times 4. All right, number 8. All right, suppose in number 8, let's suppose number 8 you had this. 6 square root of 25. 6 square root of 25. So, how can I simplify 6 square root of 25? Can I simplify this? I may not be able to. Huh? Say it again? I can simplify square root of 25. What's the square root of 25? 5. So that's 5. And so what's 6 times 5? 30. So there's your answer. So the answer is 30. 6 times square root of 25. Remember, square root of 25. 25 is a perfect square. 6 times 5 is 30. All right, number 9. You have 4 times the square root of 72. 4 times the square root of 72. Is 72 a perfect square? No. What's the largest perfect square that will go into 72, though? Use the largest. 36. So I'm going to rewrite the square root of 72. I'm going to go off to the side. I'm going to figure out what the square root of 72 is simplified. So that's the square root of 36 times 2, right? So that's square root of 36 times the square root of 2. And what's the square root of 36? So you get 6 square root of 2. Now remember, that's not the answer. That's just the square root of 72, right? But what am I doing to the square root of 72? Multiplying by 4. So that's 4 times 6 square root of 2. And 4 times 6 is 24. So the answer is 24 square root of 2. Okay. Number 10. Suppose in number 10 you had this. The square root of 81 divided by 36. Square root of 81 divided by 36. How can you rewrite this? Yeah, but even before you simplify that, how would you make... See, you're taking the square root of a quotient, right? So what I wanted you to say, now you simplify, that's the answer. But what I wanted you to say was that just like we did this, the square root of 36 times 2 is the square root of 36 times the square root of 2. I wrote as a square root of a product of the square roots. I want you to say this is the square root of 81 divided by the square root of 36. And now what's the square root of 81? And what's the square root of 36? 6. But I can reduce that. 9/6 reduced is what? 3 over 2. 3 over 2. Okay, number 11. You have the square root of 21 divided by 100. Square root of 21 divided by 100. How are you going to write that? Write that step first. What's the step? Square root of 21 divided by the square root of 100. Is there a perfect square other than 1 that will go to 21? No. So can I simplify the square root of 21? No, so I'm going to rewrite it. Can I simplify the square root of 100? Yes, because 100 is a perfect square. What's the answer? So here's your answer. The square root of 21 divided by 10. Number 12. The square root of 20 divided by 121. Square root of 20 divided by 121. How are you going to rewrite this? Square root of 20 divided by square root of 121. Good. Let's talk about the denominator first. Can I simplify the square root of 121 right away?
Yes.
Yeah, it's just what? 11. Let's talk about the numerator. And I'm going to go off to the side and kind of work on that. And here's the numerator. Square root of 20. Is 20 a perfect square? No. But is there a perfect square other than one that goes into 20?
Yes.
Which one?
4.
4. So I can write this square root of 4 times 5, right? Which is square root of 4 times square root of 5. And which of those can I simplify? Square root of 4, which is 2. So you get 2 square root of 5. So that's your numerator. So my numerator is 2 square root of 5. Can I reduce anything? No, you're done. That's the answer. So you get 2 square root of 5 divided by 11. Okay? All right, and before we do the next one, let's kind of review something from a previous course. So if I asked you to reduce 6 divided by 12, can I reduce that? Yes, because what, and I always use the largest. What's the largest GCF? What's the largest factor that goes into 6 and 12 evenly? 6. So you'd say 6 into 6 is 1, 6 into 12 is 2, right? So you get 1/2. But what if this was this? What if this was the square root of 6 divided by 12? Can you reduce that? In other words, can I reduce that 6 into 12 here? Yes? All right. No, you can't, because this is not 6. This numerator is not 6. What's the numerator? The square root of 6. So if you take your calculator out and you looked at the square root of 6, what does your calculator tell you the square root of 6 is? It doesn't say it's 6. What does it say? It's 2 point something in your calculator. So you cannot simplify this, because that's not 6. That's the square root of 6. So this cannot be simplified. Or can be reduced, I should say. Or simplified, doesn't matter. Simplify, reduce. Okay? Now it's going to help us with the next one. All right, so let's look at number 13. In 13, suppose we had the square root of 27 divided by 144. All right, how are you going to rewrite this? All right, square root of 27 divided by the square root of 144. Which one can I deal with right away? Square root of 144, which is 12. All right, let's go off to the side and look at square root of 27. Is there a perfect square other than one that would go into 27?
9.
Okay, so that's square root of 9 times 3, right?
Yep.
And that's the square root of 9 times the square root of 3. And the square root of 9 is 3. So you get 3 square root of 3. Now again, at some point, you'll be quick enough with this to where you can skip some of these steps. But for right now, just go ahead and do those steps so you don't mess up. So that's the numerator, right? Now, am I done? Am I done? Okay, she says yes. No, you're not done. Because you have this 3 here and this 12 I can reduce. So 3 goes into 3 one time. Now, before I go any further, which 3 can I reduce to the 12? The 3 that's I'm pointing to, or the 3 that's under the radical? The first one, because the square root of 3 is not 3. Square root of 3 is 1.5. something. All right, so 3 into 3 is 1, 3 into 12 is 4. So what's the answer you would write? Square root of 3 over 4. All right, good. All right, and then one more with this one. Number 14. You have negative 3 square root of 54. Negative 3 square root of 54. Is 54 a perfect square? No, but is there a perfect square that will go into 54? And if so, give me the largest. 9? 9 times what?
6.
Okay, 9 times 6. So it becomes negative 3 times the square root of 9 times 6. And I can rewrite that's negative 3 times the square root of 9 times the square root of 6. And what's the square root of 9? Okay, so that's 3. So this becomes negative 3 times 3, which is negative 9 square root of 6. So that'll be the answer. Okay? All right, now you need to be able to do this because in the next thing one of the next things we do with remember, if you notice there's no variables here, right? Okay, so that's easy kind when there's no variables. But you got to be able to simplify these because at some point you'll be adding square roots together. So we got to be able to do this before we can do that part, adding and subtracting square roots. All right, so that's going to take care of that part.